Okay, so we're going to be dealing with arc sine. So sine to the -1 like this means arc sine. It does not mean this. So I need you to know with the -1 above the trig function, it does not mean 1 over sine of x. So the inverse sine of x, if I take the sine of both sides, I get sine of y as x. So this is saying that the range, the angle y has to be between -pi/2 and pi/2. So between -pi/2 and pi/2 are what the angles have to be in order to be in the domain. So to find this, I'm going to say, okay, I need to find the angle. And if I take the sine of both sides, so I'll just write it out here, sine of √3 over 2. So I would take the sine of this side. So the sine and arc sine cancel. So I get √3 over 2 is sine of theta. So I restrict myself between these two range of angles. So only between -pi/2 and pi/2. Where is this true? So that is only true at pi/3. You're never going to add plus 2k pi on these kind of problems. So when it starts off with the arc sine, you're going to just find one angle. So this is like saying it's equal to theta. So if I take the sine of both sides, I get -1/2 is sine of theta. So when does that happen? So that's this angle here. You cannot go all the way around. You have to stay between -pi/2 and pi/2. So that means I need to go down. So the angle is -pi/6. All right, the arc tangent, right? Arc tangent, written either way, is not this. The arc tangent also has the restricted domain between -pi/2 and pi/2. So here, I'm going to set it equal to theta, and I'll say, okay, if I take the tangent of both sides, tangent of theta, so this gives me √3 is equal to tangent of theta. So I'm thinking with sine is the sine over cosine, where the sine is √3, right? I'm sorry, the sine is √3 over 2, and the cosine is 1/2. So again, we can only choose in this region between pi/2 and -pi/2. So it has to be when they're both positive, and that's going to be pi/3. No 2k pi. So here, angle theta, so if I take the tangent of both sides, I get this. Now I'm thinking, what angle is it that I get the sine and the cosine are the same numbers, so I get a -1? Well, it's got to be down here, right? It's got to be this -pi/4. So it's just one angle for the answer. All right. Arc cosine is used the least, but I just want to make sure you see it. Between 0 and pi is the range. So if I set this equal to theta, and I take the cosine of both sides, the one angle when cosine is equal to -√3 over 2 is 5pi/6. If I set this equal to theta and take the cosine of both sides, the one angle that works is pi. All right, let's finish up with this last bit here. A secant line is defined as a line between 2 points. So if I have the graph of x squared, and here's the point 1, and that would have a y value of 1, and here's the point 4, and that would have a y value. The line that goes between these 2 points, between P and Q, this line, sorry, it's kind of squiggly, is called the secant line. And I could find the slope of that line by doing rise over run, right? So P is the 0.11, Q is the 0.416, and I just know that from using the function. So if I take change in y values over change in x values, I get a slope of 5. All right, let's do the same thing with this one. So I'm just going to draw the graph. E to the -x looks like this. So x equals 0 is this point here, so I'll call that P. And x equal 2 is here, I'll call that Q. So there's a line that goes between them. So I want to find the slope of that line. So my point P is 0, and I'm putting 0 into here to get 1. My point Q would be the point 2 e to the negative 2. All right, so I'm going to find the slope by taking P, change in y values over change in x values. So e to the negative 2, subtract 1 over 2 minus 0. So e to the negative 2 is like saying 1 over e squared, right? Over 2. So 1 over e squared is a small number. Subtract 1. This would give you a negative number. This is the slope. It's negative slope, right? Because you know negative slope is moving down. You read a graph like you read a word, right? That's going down. And this had a positive slope because you read a graph like you read a word and it had positive slope.